If someone steals your credit card, you don't want the bank to find out tomorrow. You want the terminal to flash red and block the transaction while the thief is still standing at the register. Instant reaction is clearly superior for catching fraud, tracking a delivery driver, or trading stocks. So why isn't every piece of software built to process data the second it arrives? According to Sriram Gopalan in his book Bridge the Gap, which you can read at sgopalan.com, the answer comes down to physics and economics. Deciding between delayed processing and instant processing forces a strict trade-off. You can prioritize how fast the data moves, or you can prioritize how much it costs to move it. This diagram shows batch processing. Like a city bus, it waits on a schedule until it's full. By collecting millions of events, a single server crunches massive numbers at once. But if you miss the departure, you wait. In software, this is high latency. Batch systems deliberately force the consumer to wait. By sacrificing immediate answers, companies ensure their infrastructure remains highly efficient and stable. Now look at the top half of the diagram, which shows stream processing. This acts like a taxi. As soon as a single event arrives, like a user clicking a button, the system processes it in milliseconds. There is zero waiting. That speed is ideal for one passenger. But if 10,000 users click at the exact same moment, you suddenly need 10,000 taxis, and that creates a massive systemic traffic jam. Back in 2010, LinkedIn ran into this wall. Every time a user connected with someone, the search team, the graph team, and the newsfeed team all needed to know instantly. Building point-to-point connections between all these different servers turned their architecture into a tangled mess of digital spaghetti. LinkedIn invented Apache Kafka to act as a central nervous system. Instead of talking directly, user actions are written to one indestructible log. Any department can tune in, like a radio. The shipping, fraud, and marketing teams pull the exact same data simultaneously and independently. Real-time speed depends on an entirely separate, massive infrastructure layer built specifically to absorb the shock of constant traffic. And that traffic rarely arrives smoothly. If a user turns on airplane mode at 5 o'clock and reconnects at 7, 2 hours of clicks hit the server in a single instant. The system has to sort out when the events actually happened versus when the server finally received them. To survive these massive spikes, engineers use a mechanism called backpressure. It allows the processing servers to send a signal upstream, telling the incoming flow of data to throttle itself and slow down. If the incoming data acts like a fire hose and the processing server acts like a standard drain, a viral moment will flood the system. The server tries to hold the excess data in its memory until it runs out of space, and then it crashes. The trading app Robinhood experienced this collapse on a day of extreme market volatility, facing a surge of real-time transactions that their systems were never designed to handle. Because the platform lacked safeguards for peak load, it went offline for 17 hours. Customers couldn't buy or sell while the market swung wildly, leading to lawsuits, a $57 million fine, and deeply damaged user trust. Operating without a safety net under a stream of live data leaves a company vulnerable. A momentary spike in traffic easily turns into a catastrophic business failure. Real-time is often requested in meetings as if it were a simple toggle switch, but it requires maintaining a complex, expensive, and fragile ecosystem. Before building a streaming architecture, you have to ask a blunt question. Is the immediate speed actually worth the financial and operational cost? If the data is feeding an internal marketing dashboard or a monthly revenue report, taking the bus is the right move. The numbers can wait until the early morning processing window. You only pay for the taxi if the data's value expires almost instantly. Catching credit card fraud or executing a stock trade requires a live stream, because waiting even 30 seconds means the opportunity is gone. To continue bridging the gap between business ideas and the engineering realities required to build them, hit the subscribe button. Every database you pick and every data pipeline you build comes down to a business decision about what exactly you are willing to pay for.